Good morning Year 10 and welcome to this short video about the work that I have set you for the previous couple of weeks and an introduction to this week's work as well for the week ending the 1st of May. So let's go back to the previous couple of weeks so I can just explain a little bit more detail for those of you that haven't managed to fully engage or perhaps haven't fully understood the videos and the information that I've set you. For the first week, we are moving on to a new topic around forces and motion. The introduction for this was looking at distance and displacement, the differences between those two. So the tasks that I have set on Go for Schools for you are as follows. There is an introductory video, the link is here and is also on the Go for Schools. There is a worksheet on the distance and displacement and the difference between them for you to complete. And then I would like you to use the information on the physics classroom link that I've provided to make some short notes about the differences between these two, okay, with some examples, and there are some questions on there for you to attempt as well. There is then a link to a short quiz to check your knowledge, and then a consolidation task, which is the Seneca assignment that I have set, which you can start and carry on with at any time. So that is your first set of work for week 1. If you have any questions about any of that, please do let me know via email or via Microsoft Teams. Week 2, we were looking at speed, distance, time and velocity. Okay, so again, there is a short introductory video for this, okay, which you can access on from Go for Schools. There is then a sheet that is attached on Go for Schools for you to do carry out some recall work from Key Stage 3 around distance time graphs. And then I would like you to use both the Free Science Lessons video and BBC Bite Size, the links for which have been provided for you, to produce some revision notes or a revision sheet around these 4 different terms. There are some example calculations to help you. Have a go at the questions, please. And then when you've completed these, there is a test that you can take to check your understanding. Finally, the work that I would like to finish on this week is an exam question sheet which I have provided, so please complete those exam questions and then send those to me via Teams if possible. If you're not sure about using Teams or if you haven't been able to access that, then please do email that to me. There is also an Educate quiz on forces and motion as a consolidation task. On to this week. So this week we're looking at the topic of terminal velocity. So there are 4 main tasks for this. There is a Kahoot quiz, which is a recall quiz. The pin code is provided there, so you can go onto Kahoot and do that at any time, please. That will be available for the next few days. There is a short video on the science of skydiving, which I'd like you to watch as your introductory video for this task. And then the next points I'm going to go through on these slides. The main key points about terminal velocity, and then a home practical experiment for you to attempt. Your consolidation tasks will be both the Seneca and the Educate assignments that I have set for you. Okay, on to this terminal velocity, some of the key points. I've provided a worksheet that looks like this for you. You can either print this out, or you can open it in Word and type your answers into the spaces that you can see where the describe and explain parts are. If you're unable to, you may be able to add some arrows by inserting arrows and adding them here. Okay, if you're able to do that. Okay, if not, then you might want to just draw a little picture yourselves in your books. You could also draw all of this down into your books as you go, if you prefer to do it that way. Okay, so you're going to work through this. I'm going to explain some of this to you, okay, as to what's happening to a skydiver as they're falling, and you're going to be able to hopefully use that information to describe the motion and explain why the motion is the way it is, thinking about the forces that are being used. Okay. So before that, there is a short video which is going to play for you. Okay. see if that works. Okay, yeah, here's the short video, okay, about a parachute jump. So you can see what's happened is that the parachutist has just turned the volume down a little bit. Okay, so you can see that the parachutist, the skydiver, has jumped from the plane. They're videoing him from somebody else that is skydiving with him is videoing him. He's currently free falling. Okay, he has no parachute out. Once you watch his body position, and then he opens his parachute. And we think really carefully about what happens when he opens his parachute. That is the key point here. Okay. The person video also has opened their parachute now as well. Okay, brilliant. So let's look at a velocity time graph for a parachutist. Okay, so I'd like you to draw this in your book or on some paper. It doesn't need to be graph paper at all. It can just have a picture that looks a little bit like this. Draw a little grid or just draw an axis of time and velocity. Okay. And we're going to add some lines to our graph. Okay. So as our parachutist, our skydiver, jumps from his plane, his speed is increasing. Okay, his velocity is increasing. And you can see that by the increase in that yellow line over a period of time. But then at some point he reaches his speed no longer increases. Okay, and at this point we say his terminal velocity is reached. He cannot increase his speed anymore, and we'll look at the reasons for that. Okay. Then what happens? He opens his parachute, and the skydiver starts to slow down. Okay, he doesn't stop. He doesn't go backwards. He doesn't go back up into the sky. His speed begins to slow. Okay, and then at a later point, eventually he reaches what we call a lower terminal velocity, so a point where his speed is no longer decreasing, and he continues at that speed until he reaches the ground. Okay, so you should produce a graph that looks a little bit like that. You can pause the video here to help you. I'm going to move on. Okay, so onto your home experiment. Okay, and we're going to do some consolidation and learning from all of this as well. Oh, sorry, to go back. The worksheet that you have, okay, I would like you to go through that and describe the different stages of the skydiver and what you think is happening at each of those stages in terms of the forces that are being exerted on the skydiver at different points. And we will look at that as our starter in next week's lesson. So, your home experiment. I have produced a video for this, which is also on the YouTube channel, but you're going to create your own parachute and do some experiments with it. What you're going to need is a sheet of A4 paper, some scissors, something to draw around that's circular, pencil, ruler, and something to stick up with either glue or some stapler or something similar. Okay, so on your paper you're going to draw a large circle that fills the page, then cut that circle out, okay, and then divide the circle into equal segments. So you can do that by drawing lines from the center to the edge, and the easiest way to do that is to fold the circle into half several times. You'll see on the video how that works. You're going to cut along one of those lines to create a 3D mini cone. Okay. Then choose somewhere in your house or outside from which you can drop the cone. Okay, and someone can hold it whilst you time it, or the other way around. You need to be able to measure that height though. You're going to do that 3 times, and you're going to record your results, the time that it takes for the cone to hit the floor. You're then going to adjust your cone, change the number of segments that overlap, and repeat it. And continue until you've done as many as you can, okay, and your cone is a completely different shape. And then you're going to draw a table of your results. And if you've got any graph paper, or if you're able to create a graph nicely, you can or you've got something on a computer that you can use, you can draw a graph of your data. Okay, so all of that information, okay, should be sent to me on Teams if possible. You should be able to access Microsoft Teams now. Good luck with that experiment, and I'm going to leave you with a short video of somebody who took skydiving to the extreme. I'll speak to you all next week.
Start removing here in a little bit. Let's do a little bit. Release.
If you're scared, walk away. Cause there's no need to feel ashamed. Yeah, we all feel the same. Where's your passion? Where's your fire?
Alright, now the whole road is looking I'm going over.